Hi everyone, today I'm going to talk about the quadratic equations in three forms. Here we have the graph of a parabola. Even though this is one parabola graph, there are three equivalent equations that can describe this graph. The first type of equation that we might see is factored form. The factored form equation for this graph is y equals x minus 3 times x plus 1. And we know from before that the factored form equation gives us the x-intercepts or zeros, and it tells us that they are at -1, 0, and 3, 0, which we see right there. If I take my factored form, those parentheses, and I multiply it out by foiling or doing box method, that will give me the standard form equation. So this is the standard form equation for this graph. Both of these equations are equal. And the standard form equation, remember, tells us that the y-intercept is at 0, -3, because the last number in that equation is -3, which we see right there. How do I go from standard form back to factored form? I just have to factor it. Okay, I just have to factor my equation, and that'll go back to factored form. The last type of equation that we've seen is vertex form. This is the vertex form equation for this parabola, y equals x minus 1 squared minus 4. The vertex form tells us that the vertex is at 1, -4, which we see right there. Now, how do I get between standard form and vertex form? Well, to get from vertex form to the other one, I can multiply this x minus 1 squared. I can multiply it out because that's x minus 1 times x minus 1, and then subtract 4. So once I do that and combine like terms, it will come back to the standard form right here. To get from standard form to vertex form, it is using a process called completing the square. We did not talk about completing the square this year, but that's okay. You will learn more about it in Algebra 2, and if you're interested in finding out more about completing the square, you can definitely Google it and find tons of resources on that. The last thing I want to point out is that all three equations do show us that the parabola is pointing up because the coefficient at the very front is positive.